Hello all, welcome to Improve 10x. As part of test-driven development series, we are trying to solve another problem today. Let's get started. So, in bowling game, the scoring is actually a bit different compared to normal games. So, they'll have a scorecard, which we will be discussing today, and we will implement that using test-driven development. And in test-driven development, we have already seen red, green, and blue. First, write a test that fails, and green, write code that passes the test, and blue, which is a refactor, where you can clean up your code and make sure it runs all the tests successfully. Let's understand the problem first. This is the primary block. So once you understand the problem clearly, then you can actually solve it easily. If you don't understand it in detail, it might create a problem when you are actually doing coding. So let's see the scoreboard here. In bowling game, we have 10 different frames. Each frame will have two rolls where a person has to roll like target all the 10 pins. And you can see here in that each frame you have two numbers which are like two rolls. And in the 10th frame we have three rolls. We have some reasons for them also. So let's discuss one by one. First, a user can actually roll the ball and then he can target the pins. And if he clears all the pins, that is called as a strike. And it is marked as X. In the second frame, you can see it. And if you get a strike, you don't need to roll next second time. But in terms of score, you are going to get the next frame score into the current frame. If you see the score here, in the first frame, it has 7 plus 2, which is 9. Pretty straightforward. In the second frame, you have got only 10 pins, but the score has become 29. Previously it was 9 and here we are getting 20. So how did we get this 20? It is this 10 pins plus the next frame. If you see in the next frame, the person has taken all the 10 pins in two rows, 6 and 4. That is the reason it is adding 10 plus 6 plus 4. Overall it is 20. And the previous score is 9. So it became 29. So this is called as a strike. So the next terminology is spare. And in the third frame, you can see there is something called slash, which means in the first row, user has taken 6 pins, and in the second row, user has taken the remaining 4 pins. So in the complete frame, they have taken 10 pins. This is called as a spare. And whenever you do a spare, you get the current frame score plus the next roll score. If you see here, in the third frame, user has taken 10 pins, and in the next roll, user has taken 2 pins. So the score of third frame will be 10 plus 2 plus the previous score, which is 29 plus 10, 39 plus 2, 41. So this is how we actually calculate the score. Now we are going to implement a method which will actually calculate the score of this scoring board. Okay, let's start the coding. First, as part of TDD, we'll create a test class. I'm creating a package for that. We'll call it as bowling. And let me create a test class. Game test. Done. And we need to check whether the test environment is working properly or not. So let me write empty test. Let's run this. It is working fine. Now, so first, in a game, we should be able to roll, right? So let's write a test for that. Test public void can roll. And now we need a game object. And here we can see the red color. So we need to fix this. Let's create a class called game. We'll create that in the Java folder. Done. We have created the class called game. Now the next part is we should be able to call the method roll, and we need to pass number of pins into that. Let's say maybe 1 pin. We have got into the red. Let's try to create a method roll, and we'll call the input as pins. Done. Yes, if we run the test suite, we are able to call this method. It is working fine. Let's test for the first one, which is first use case where we are rolling like 0 pins in all the roles. Test public void, and we call this as gutter game, where we are actually rolling all the values as 0. So first let's create a game object. Done. And I am rolling the roll method 20 times. I equal to 0, I less than 20, I plus plus. And then I am calling the roll method with 0 value for 20 times. And now the score should be 0 because we haven't got even a single pin. So let's do the assertion. Assert equals, let's me import statical, and then the expected value is 0, and we need to have a method to get the score also. Score. Done. Now we don't have a score method, so I'm creating the score method, which will return an integer. Default it is returning 0. Now let's see if the tests are actually passing. Good, everything worked fine. Now let's go for the next test, where we are actually rolling all ones. Test public void all ones. Let me create a game, new game, and now I need to roll 20 times, right? 0 to I less than 20, I plus plus. And what value should I roll here? We have to get a single pin in every roll, right? So I'm calling it with 1. Now what should be the score? 20 pins, it should be the 20, and we are checking for dot score. Done. Now let's try to run this test suite again. It failed. Let's get into the game and try to fix this problem. So till now, like we were actually solving problems where the method was independent, like whatever the input is given, it is just dependent on that. But now we are going to solve a problem where we have a relation between these two methods, roll and score. Score is dependent on the roll method. So whatever the values that you pass, we have to store that, and based on that the score will be calculated, right? So we need a variable at a class level. Let's call that as private int total pins equal to 0. Now whenever I do a roll method, I have to add the pins into this total pins. Done. And now in the score I can just return total pins. So this should give me like 20 for the current test case. Yes, all the test cases have passed. Perfect. Now let's get into the game test, and we will see if we can do any refactoring, if we can do any cleanup. There are multiple things. First one, game object is created 3 times. So we can put it into the setup. So let me take this. First we'll create a variable private game. Done. And we need a setup method. Before each public void setup, and then I'm setting the game object here. Done. Now I can remove the game object creation everywhere, right? Let's see if all the tests are working fine. Yes, all the tests are working fine. So what next can we do? If you see here, this code actually looks very similar to this code, right? So what we can do is, let's create a separate method for this. First thing, int number of rows is equal to 20. So I'll just change this to number of rows, and we also need to mention number of pins, right? Pins equal to 0. So here I can take this as pins. Done. Now if I can extract this particular for loop, extract it, and we can call it as roll many. And there is another occurrence also, so just replace it. So have you seen here? IntelliJ itself has done the magic for us. Now I don't need these two variables separately also. I'll just put them in line. So I'll just put 20, 0. Let's run this. Yes. So now my code looks much better and all the tests are passing. Shall we move on to the next scenario? So we have covered all zeros and all ones, right? We will also just move these methods up. Now let's get into the next one, which is a spare. Spare means in the first, in any frame, you should be able to hit 10 in 2 rows. So let's take a test case for spare, public void 1 spare. And let's consider we are hitting like 5 in first row, 5 in second row, and the score actually depends on the next row also. So let's take maybe like 4. Okay. So the score should be, in the first frame we are getting 10 plus 4, 14, and in the second frame we are getting 4, which is 18, right? Now let's try to do these things. First one, we need to roll 5, and we need to roll again 5. We need to roll 4. Now this is done. Now we need to check for the remaining rolls also. So we have completed 3 rolls and the remaining are 17 rolls. So we'll roll all zeros for them. 17, 0. Now let's check for the assertion. What should be the score? We already calculated, it should be 18, and we are calling the score method. Done. Now let me remove this comment. Let's run the test suite. It failed. Let's get into the game, and now we'll try to solve this problem. So before solving this problem, we have another major issue, which is, if you see the roll method, it is actually doing the calculation for the score. And if you see the score method, it is just returning a variable. Does it look good? Ideally, the calculation should happen in score, right? And roll should just only store the value or something. And this is very essential for spare, because in spare you need the next roll value also. So let's try to comment the current test case, and then we'll try to fix this problem first. Whenever you roll, we wanted to store the values, right? And for storing, like just total pins is not enough now. We need an array. Int rolls equal to new int, and total we can have 21. Like every frame will have 2, and the last frame might have 3 also. So let's take 21. Done. Now in the rolls, I just need to store the value. I should not do any calculation. And for storing, I need an index also. So let's take an index also. Private int current roll index equal to 0. Now I'm going to store rolls of current roll index is equal to pins. Done. And I don't need this calculation anymore. And once you set the value, you have to increase the current roll index also, right? Done. Now in the score, I need to do the calculation. So first, I don't need this total pins anymore. What I will do is I'll just declare a local variable, int total pins equal to 0. Now I need to add all the values inside the rolls. Int I equal to 0, I less than roles dot length I plus plus. Now we need to add the pins to total pins, and the value is in the array roles of I. Done. Now let's see if all the previous test cases are actually working fine or not. If they are not working fine, which means we have done some mistake. Perfect. It is working fine. Now let's come back to the spare. Let's see if spare is already working. Ideally, it should not. Let's see. Yeah, it is not working. So let's get into the score method. Now we need to modify the score method, and we need to check if it is a spare, how to calculate it. And if you try to analyze, spare is related with a frame. A spare can be done only within a frame. You cannot do a spare with second and third rows, right? So doing a for loop with 0 to 21 is ideally not a good idea, because we want to check whether both the roles are in the same frame, right? So let's try to change this into a different approach. Instead of I, what we will do is we will do frame. If I equal to 0, frame, and total how many frames do we have? It's a standard 10, right? Done. Now, how are we going to calculate the score in each and every frame? We have to check for the frame value and the number of rows also. So we need an index for that. So let's take first in frame as an index, which will be 0. So now if you see here, if you are in the first frame, we are taking the first ball, which is like first in frame plus roles of first in frame plus 1, right? And after this, we are done with the frame. So we have to increase it by 2. What should be the value? First in frame should be increased with 2. Done. Now let us see if this is actually making any change. We did not do for the spare. We are just checking for the other test cases. All the other test cases are working fine. Now we will look for the spare. So in any frame, if we want to check for spare, we have to check whether the first row and the second row, they both actually add up to 10. So if rows of first in frame plus rows of first in frame plus 1 is equal to 10, right? This is the condition for spare. So I'm just adding a comment so that we can do some refactor after this. If it is a spare, what should the score should be calculated like current frame plus next row also. So the total pins should be current in current frame. We know that it is 10 definitely, and then we need the next row also. So rows of first in frame plus 2, right? And then we have to go to the next frame. For that, again, it's the same thing. First in frame plus equal to 2. And if it is not a spare, then we have to do the normal calculation, which is already there, right? So I think this looks good, and this should solve our problem with a spare. Let's see. Yes, it covered the spare. Shall we try to do some cleanup? So if you see here, I want to make sure people, whoever read this code, they should understand that this is actually calculating whether it is a spare or not. So I'm going to extract this into a separate method. Is spare. Done. Now here also, like I don't know what kind of calculation is actually happening here by just reading it. So I want to give this a method. Extract. I'll call this as first in next frame. Done. Okay, so this should be good enough, and it looks better also. Now I don't need this comment. our methods itself are actually explaining what is pair and all. And now let's get into the game test and we'll check it for a strike. At the rate test public void one strike. For the strike, you need to hit all the pins in the first roll of a first frame, any frame. And the score depends on the next frame score as well. So let's try to take one example. First you are hitting 10 and then you are hitting maybe like 4 and after that you are hitting 2. So now the score will be, in the first frame you will get 10 plus 4 plus 2 which will be 16, plus in the second frame you are going to get 6. So the score should be 22, right? Let's try to simulate this. Game.roll. The first roll we are hitting 10. Next. Game.roll. In the second roll we are hitting 4. In the third roll we are hitting 2, right? Now, how many rolls are available still? In the first frame we have completed 2 rolls and we have in the second frame we have 2 rolls. So we have another 16 rolls to finish. So let's give zeros for all the 16 rolls. Number of rolls are 16 and the pins of 0. Done. Now we need to assert the value. The score is 22 which we are expecting and we are calling the game.score. Done. And we can remove these calculations. Let's try to run this. Yes, it is failing. Let's get back into the code and we will see. This is actually giving you the spare condition and this is giving you the normal condition. So now we need another condition which will actually check for strike. And what is the strike condition? We need to check the first in frame index, right? Rolls of first in frame is equal to 10. If this happens, which means it is a strike. Otherwise, we'll go for else, which is a spare or the other conditions. Now, whenever strike happens, what is the score? Total pins plus equal to, first we are getting the strike value which is 10 plus we need the next roll which is rolls of first in frame plus 1 plus rolls of first in frame plus 2. Done. Now, after this, how many times do we need to increase first in frame? Here we have taken only one roll, right? So we can just increase by 1. Done. Now let us see if this works. It worked. So we have implemented it for strike also. Shall we do some cleanup? I think we need some cleanup, right? We have a comment here. Let's try to avoid that comment. So this is the condition which will actually tell you whether it is a strike or not. Let's extract it to a separate method. Is strike. Done. Now I don't need this comment anymore. And here if you see, this is actually giving us the next frame result. Right? These are required for strike, right? So let's extract this into a separate method. We'll call them next 2 balls for strike. Done. And here also we can actually do some refactoring. So extract this. Two balls in a frame. In unnecessary keep original signature. Yes. So now if you see here, like most of it is like very simple and easy to understand also, right? Let's try to run the test suite and see if everything is working fine. Perfect. All the tests are working fine. Now let's do one more refactor. See here if you see, like initially we gave the name called total pins, but now it is not actually calculating total pins. It is actually calculating the score in each and every frame. And there is a complex logic for that calculation also, right? So let's call this as total score instead of total pins. Total score. That makes it better. Done. Let's run the test suite again. So our algorithm is almost ready. If you see here, inside the for loop, we are checking for strike and we are doing the strike calculation. We are checking for spare, we are doing the spare calculation, and we are doing a normal calculation also. I don't see any extra behavior over here, right? Do you? So everything is looking good. Let's get into the test and see if we can do any cleanup. The methods are pretty simple and easy to understand. But what we can do is, instead of putting it like this, like all the roles here directly, let's extract them into separate methods. We'll call this as a spare. Let's extract this. We'll call it as spare. Done. Similarly, for strike also, we can call this as strike. So I'm going to extract this part. And then I'll call it as strike. Done. So even these methods also, I'll just put it at the top so that like it will not disturb our tests. Similarly, spare also, I'll just move it to the top. Done. Now if you see, we have gutter game, all ones, one spare, one strike, and it covers all the test cases. Let's run and see if everything is working fine for one last time. Everything works good. If you see our method, our algorithm has hardly like 14 lines of code. And it solved all the test cases, right? We have completed the program. Now let's try to test with this particular scoreboard. Let's try to roll with these values and then we'll see whether we'll get a final value which is a 98. Shall we? Come. @test public void scoreboard. So now if you see, we have to give these values 7, 2, 10, 6, 4 and these values. Let me try that. Game dot roll 7. I'll just keep these values and then we'll just keep modifying the values. 7, 2, 10, 6, 4, 2, 5, 8, 1, 2, 2, 5, 5, 3, 3, 4, 2, 5, 5, 2. So these are the roles that we are going to do. And the final output that we are going to expect is 98. So let us see. Asset equals 98, comma, game dot. Shall we run the test suite? it passed. So we did not consider much about this kind of complicated inputs or anything. Just we tested for one spare, one strike, and now when we tested for the entire scoreboard, it worked perfectly well. There was no problem at all. And while refactoring also, like our test suite actually helped us a lot in terms of making sure we are not breaking any functionality. And we can keep on increasing our test suite like whenever we find corner cases. So this is how test-driven development helps us in implementing incremental algorithms. Thank you so much for watching the video, guys. If you have any questions, please comment. We'll get back to you. Thank you.